Assalamualaikum. My name is Siti Nurifa Batisha binti Jamsari. I'm from AS123B.
Hi and Assalamualaikum. My name is Nur Farisha Hanis binti Hanif and I am from AS124B.
Hi, Assalamualaikum. My name is Muhammad Shaikal bin Muhammad Faiz and I'm from AS1243B.
Hello, my name is Muhammad Hakimi bin Azman and I'm from class AS1243B.
This abstract discusses research on hazard analysis and evaluation in construction site aiming to improve safety procedure and reduce risk. The study used a comprehensive methodology including qualitative and quantitative techniques to identify, evaluate and rank common risks. It explored methods like HAZOP, FMEA and GSA and integrate technologies like AR and BIM for real-time hazard identification. The research also assessed safety management, safety and organizational culture impact on a proactive hazard prevention strategies. The finding contribute to existing knowledge and aim to inform stakeholders for a safer construction sector.
Construction, a fragmented sector with numerous independent firms, is vital for urban landscape, transportation networks and essential facilities. It provides employment and economic stimulation in architectural design and engineering. However, it faces challenges like safety concerns, regulatory complexities and environmental considerations. The industry is considered hazardous due to high accident incidences resulting in fatal injuries, disabilities and occupational disease. To address these issues, a comprehensive approach including enhanced safety training programs, strict enforcement of safety guidelines, improved hazard communication and the integration of advanced technologies is needed. Objective of these studies is to identify hazard and health exposure in construction industry, to evaluate their effects on workers' health, to determine the industry's environmental impact, to develop effective mitigation strategies and assign each hazard for corrective action to minimize risk or eliminate them. Significance of study. This study will redound the employer risk-free from accidents and injuries by taking action to maintain a safe working environment in the construction industry. Construction industry is a global economic driver, contributes to job creation and economic growth. Despite contributing to employment, the industry is considered hazardous due to high accident incidences resulting in fatal injuries. This due to physical hazards such as falling objects, confined space and machinery-related injuries. Construction also causes environmental impact and electrocution hazards. Physical hazards. Physical hazards are tangible elements in the environment that can cause harm or injury, often posing a direct threat to workers' physical well-being in the construction industry, such as falling from height. Falling from height is the most common accident like scaffolding, rooftops, ladders and platforms expose workers to the risk of falling, causing serious injuries like fractures, spinal damage and even death. These falls are chronic hazard in the construction industry. Second, slip, trip and fall. Slip, trip and fall incidents are common safety hazard in the construction industry due to its dynamic nature, including trailing cables, uneven surface, loose mat, varying heights and wet or contaminated floor surface due to unpredictable environmental conditions. Third, falling objects. Construction sites often involve multiple floors and heavy equipment, causing injuries from falling materials, substances, hand tools, and appliances. Unstable tools can dislodge unsecure equipment on scaffolding, drop materials of incidental knock-offs. Next, confined space. Construction sector fatalities in confined space mainly involve physical and atmospheric hazards. Physical hazards include landslide, falls, electric shocks, burns, drowning, and concrete wall collapse. Atmospheric hazards involve poisoning and asphyxiation like high nitrogen concentration during underground pipe cutting. Next, mechanical energy, including noise, vibration, radiation, and temperature extreme. Noise, vibration, radiation, and temperature extreme in construction site pose physical injury hazard, including hearing loss and inevitable due to nature of construction activities. Chemical hazards. Construction workers face chemical hazards such as asbestos, welding fumes, spray paints, oil mist, solvents, and hexavalent chromium, with dust being the major hazard along with the asbestos, cement, and adhesive. Health hazard. Health hazard can be acute or chronic, presenting varying risks to individuals. Acute effects are immediate and short-term effects, include workers falling from height, electric shocks, ladder work, heavy lifting, harmful chemicals, fire, emergency excavating, and protective clothing. While chronic effects result from prolonged exposure to substances, often leading to long-term health issues or disease. Construction workers face chronic health hazards such as exposure to corrosive materials, irritants, vibration, noise, and other hazards, leading to back pain, upper limb disorder, dermatitis, respiratory disease, and decompression illness. Environmental effects from construction industry. The construction industry significantly impacts ecosystem, air and water quality, and contributes to environmental degradation through activities like raw material extraction, deforestation, and landscape disruption. Air pollution. Construction materials production, including cement, asphalt concrete, and glass, significantly contributes to air pollution and energy consumption, with the cement industry polluting on four fronts. Habitat destruction. The construction of new populated areas worsen environmental conditions by affecting ecosystem, causing changes in gravitation, thermal magnetic fields, and groundwater composition, leading to an artificial environment. Electrocution hazards. Construction occupations with high electrocution risks include overhead and buried power lines, cranes, and main baskets, which pose hazards such as electrocutions, burns, and falls from elevation.
The construction industry presents risks such as exposure, workers' environment, and community risks. To gather relevant data, a literature search was conducted using Google Books, ResearchGates, and ScienceDirect database. Keywords such as hazard, effect, and construction were used to locate relevant articles and journals. This research aims to provide a comprehensive understanding of these risks.
Result and discussion. Hazard prevention and control. The table below shows that the first step is hazard identification, which includes work activity followed by the hazard that result from the work activity and the effect that it causes. Following that, risk analysis is performed, which includes existing risk control, likelihood, severity, and risk level. Last but not least, risk management includes the recommended control measures and the person in charge, PIC. Based on the hierarchy form Table 6, we can see that there are 4 hazards with a high level of risk that can result in death, serious injury, or permanent disabilities. High risk hazards include fall from great height caused by drilling in a high pace, noise hazard from drilling, and welding fumes that can irritate the eyes, nose, throat, and lungs. There is also the danger of electrocution that can be dangerous to human health and which causes severe burns and tissue damage. Falling objects, slip, trips and falls, confined space, respiratory disease, air pollution, and even habitat destruction are examples of medium risk that can be found in the construction site.
The purpose of this hierarchy form is to identify potential hazard in a company to assess the probability of an accident or financial loss. In this case study, we managed to identify the hazard that may occur in construction industry. There is falls from height, falling object, slip, trips and falls, confined space, noise, welding fumes, respiratory disease, air pollution, and the last one is habitat destruction. All came with the risk analysis and risk control.
Noise hazard. First, elimination. To reduce noise level at work, companies should plan and implement a suitable hiring or purchasing policy. The most effective long-term measure is considering how new machinery or work process will function without exposing employees to excessive noise. Contacting the supplier or manufacturer can help determine the noise level of new equipment, including installation, specification, planned maintenance, and expected noise level under specific operating conditions. Second, substitution. Organizations should explore various tools and methods to minimize noise on the job. Hydraulic operation, for instance, can reduce noise and protect workers. However, a risk assessment is necessary to ensure this method do not introduce new hazard. Next, engineering control. Two engineering approach to reduce noise in the workplace, including separating noise area and enclosed loud equipment. To reduce reverberation noise, use plastic bumpers and absorbent materials on surfaces. Increase the distance between the noisy source and employees. Administrative control. Administrative measures to reduce noise pollution include identifying hearing protection zones, labeling loud areas, increase worker distance from noise source, scheduling noise job when the fewest people are present, and rotating jobs to minimize employee time spent in noisy environment. These measures aim to minimize the impact of noise on workers and promote a healthier work environment. Next, PPE. Hearing protective must be free for employee to wear. Reduce noise exposure and allow conversation without removing it. It should be appropriate for the worker environment and compatible with other PPE like hard hats, dust masks, and eye protection. Offering a variety of protection options allows employees to choose the best fit, making HCP use more compliant.
For the confined space control measure, the first one is elimination control. Elimination control aims is to eliminate the need for workers to enter confined spaces whenever possible. The second one is substitution. Substitution control is an action for switching materials to less hazardous materials, and work practices is an effective substitution for decreasing confined space concern in construction. The third one is engineering control. The most effective is creating physical barriers between workers and any remaining hazard within the confined space. The last one is personal protective equipment, PPE. The PPE is a must for a worker to wear before entering dangerous confined space to perform construction tasks.
Next, fall from height. First, elimination. Managers should consider engineering out fall risk instead of relying solely on administrative or PPE controls. Elimination measures include building structure on the ground, pre-assembling rooftop components using elevated platform, installing window openings after fall protection barriers are ready, planning installation sequences, and implementing suction-mounted lift. Second, substitution. The construction industry faces significant falls from height, leading to serious and fatal injury. Substitution control aim to reduce fall hazard by replacing hazardous surfaces with safer alternatives. These include using scissor lift and guide rail instead of ladders, erecting precast panels at ground level using mass climbing work platform, building roof trusses on the ground, and using aerial drones for inspection. Engineering control. Engineering control for falls include fixed guard rail, parapet walls, active travel restraint system, safety nets, debris netting, custom work platform, holes cover, temporary flooring, and control access zones. These measures create hard barriers against fall and direct work activities away from leading edge and opening. When properly designed and implemented, these engineering solutions create hard barriers against falls and constrain work activities. Administrative control. Administrative controls are crucial in mitigating fall hazard during construction work at elevation. These include comprehensive fall protection plans, designated safety monitoring system, limiting access to areas without adequate fall protection to essential personnel, implementing right-to-know training programs, and suspending non-emergency work during severe weather or high wind conditions. These secondary protection help ensure safety and prevent accidents. Lastly, PPE. Personal protective equipment is crucial for construction workers who cannot completely isolate themselves from fall hazard. It includes full body harness, shock absorbing lanyard, self-retracting lifelines, rope grabs, descent device, double locking snap hooks, carabiner, and horgans. PPE is required according to job hazard analysis. Workers must maintain, adjust, Store and inspect PPE to avoid ineffective performance. Regulator require PPE as a supplementary measure for residual risk after stricter control have been implemented or when more reliable systems are deemed infeasible.
As for the slip, trips and fall control measure, method number 1 is elimination, which eliminate the obstacles that can risk worker safety, for example, setting floor and wall openings for mechanical and electrical components. Also, clean up any spill immediately. Number 2 is substitution. For example, replace traditional steel grates with molded drainage grates to allow safer crossing over trenches or excavation. Number 3 is administrative control. This control establish designated zones, limiting material loading high, implementing daily cleanup policy and conduct regular surface inspection. It's for reducing the probability of slip, trips, fall hazard. The last one is wear personal protective equipment such as footwear with heavily large soles, glove and high visibility vests or accessories.
First, elimination. To prevent electrocution and burn injury on construction sites, it is crucial to eliminate electrical hazard. Managers can implement controls during the design phase, such as creating physical separation and barriers between high and low voltage system, installing permanent lighting circuit, and planning dedicated space for temporary power panels, removing work near live parts, replacing conductive materials and tools with non-conductive ones, and designing barriers between workers and hazard are more reliable than relying solely on administrative warning, PPE and proper training. Next, substitution. Construction companies can mitigate electrical hazard on sites by replacing dangerous equipment, materials or work process with less hazardous alternative. These include choosing hydraulic elevating work platform, using non-conductive ladders, installing advanced fault detection breakers panel, using battery power or pneumatic hand tools, planning sufficient task lighting, prohibiting improper termination of aluminium conductor, enclosing live bars, and replacing arc flash resistant clothing fabrics. While not all electrical work can be eliminated, substitution can reduce the likelihood of energized work, spark hazard, conductive equipment selection, and other life exposure risks. The administrative control. Construction project requires stringent administrative procedure to manage electrical work. These include lockout, tap-out programs, limiting access to high voltage room to qualified personnel, systematically analyzing hazard and mandating reduced PPE, increased supervision planning and job briefing are also necessary. Wearing conductive metals near electrical system is prohibited. Non-compliance disciplinary policies are enforced. On site safety, watches are designed for high-risk tasks. Assure equipment grounding conductor programs, manage receptacle testing, and voltage detector testing is required before manipulating cords and breakers. To safety protocol, reduce human error in life system. Next, PPE. Electrical hazard analysis revealed that necessary equipment includes flame-resistant clothing, leather protector, certified de-electrical hats and eye shield, and heavy-duty insulated glove. Extensive inspector and user training ensure proper coverage, care limitation, and inspection of PPE for accident prevention. PPE is the only adjustable control largely dependent on human behavior, not fixed barrier. Although not completely eliminating the risk, through protective equipment protocol can help. The equipment should be rated for specific calorie intensity and should be inspected regularly to ensure safety.
The last control measure is for welding fumes hazard. First one is substitution. Choose bolt-up or riveted connection instead of welding fabrication and use adhesive bonding instead of welding when high strength is not required. Second one is engineering control. For example, local exhaust ventilation system with freely movable fume extractors, flexible ducting and adequately sized hood located near the plum. The third one is administrative control. Use policies, procedures, and work practices rather than relying solely on engineering barriers or PPE. The last one is personal protective equipment, where such as N95 masks for dust, powered air purifying respirators with positive pressures, and supply air respirator system.
The construction industry faces numerous hazards that require careful attention and proactive measures to ensure worker safety. These hazards can arise from project planning to completion, posing threat to physical health and overall well-being. Identifying, assessing, and mitigating these hazards is crucial for secure working environment. Safety measures must be integrated into all aspects of construction activities, including structural and procedural elements. Recognizing these dangers and implementing comprehensive safety protocols can reduce accident and increase awareness and adherence to safety guidelines. The construction industry faces persistent hazards such as falls, electrocution, and exposure to harmful materials. To address these hazards, urgent and proactive measures should be implemented across all levels, including governmental policy, organizational management, and site-level operations. This includes mandatory safety education programs, strict enforcement audits, and promoting safety culture, robust risk control measures, and collaboration across stakeholders. By proactively identifying and controlling risks, the industry can achieve zero harm goals and improve worker safety.